Programming. Probably one of the most, I would say basic, but not really the most basic things out there, but one of the biggest things that's going on right now. And you, yes, you want to learn it. Now, this is the most basic video with zero actual programming. The way this video is going to be is I'm just going to be telling you the most basic. Yes, I'm using paint.net for this with like the worst handwriting ever. That is not an S. 1 second. It was basic. See, basic stuff. It's mostly gonna be like just explanation of everything to get you ready for whatever is gonna happen to you. I say like something's bad's gonna happen, but don't worry, nothing's bad gonna happen. I promise. So programming is actually really relatively easy, in my opinion at least. And the biggest thing is the beginning of the beginning things I'm going to be talking about right now is what even is, programming. So let me just pick like a color red, okay? Because like a lot of people, how do I say this? They're mostly not afraid, but they're confused. What is program? I'm gonna misspell it. Is it? It should be 2 M's. Unless I'm tweaking. That's where it be. Anyways, what is programming? So what is it? No, I'd say programming is imagine. Let's see how to explain it. So like imagine you go to the grocery store, right? So like I'm not gonna use a specific name of a store, but that's a really horrible. So I cannot draw straight lines. That does not work. So there's a store, right? Imagine you're going to the store. The store's name is the store's name is store. You know what store it is. And like you have. That's not paper. Close enough to a paper. Oh, yo, am I stupid once then? Okay, here we go. That looks more like a paper. And like imagine you have your list with like one apple, two pear, and like etc etc etc. And well, I guess in the actual list don't go, but let's say they're in order of the layout. So like, you walk in, you get the apple, then you get the pear, and then you get all the other stuff in order. That's pretty much what it is. It's pretty much a list of tasks, of instructions that the computer, computer, pretty much computer. So what is the biggest? Okay, let's talk about first thing. What is computer? I'm not gonna go too much into this, as in I'm not gonna say the scientific name of this. What I think, or like what you can easily call computer is just like the most easiest, most basic thing, like really basic, is literally something that like follows instructions, as in like you can say a code, yeah, like what follows the code, but pretty much something you need to like in a way program for it to run a thing, so the ouch, like that looks like a microwave. But this computer, guys, I can't. God. Yeah, okay, yeah, so like this is a computer trust, keyboard and stuff. So like it's like the most basic like thing about when you think of computer, you think of this thing, but it could be other stuff. For example, robotics. You can use to program robotics, like you have the cloud, right? You have the cloud. So guess what's controlling the cloud? That's right, a computer. Or I'd say bots, like the AI itself. It's literally a computer. Like I'm pretty sure AI is gonna like any type of intelligence is considered a computer. Because you think it's like it has, no, it doesn't. It really just follows instructions, bro. It follows a specific code, which AI just goes online, just like takes information from on other sides. So literally just used for like a quick information like grabber, but it's actually horrible. By the way, the moment you're gonna get into programming, you'll quickly understand that your skill. Oh, that's horrible. Okay, your skill is like much bigger than AI's. You'll quickly understand how useless AI can get. Like it's useful for like a quick little, a quick little block. But the moment you're gonna start to get into like a bigger one, it's just, you have your code, and then it just like, it just scrambles everything, and then you have a normal code. You just so much stuff. But oh, sorry. Okay, calm down. Tweaking out right now. So programming is literally just this list of instructions that the computer, because the computers are not smart. Okay, if you were to right now look at your computer, I'm gonna try to draw a proper computer now. So if you were to, I don't know why I choose black. I'm gonna choose white because easier to see. So that's a weird computer form. Imagine this like, yo, my computer gets worse and worse each time I draw it. So imagine you. Okay, so this is you, and you have to like start telling them like, make me a game. This guy ain't gonna do nothing. Okay, unless he has like AI open and like you tell it to like make a game with like your voice, maybe. But by the way, AI is not gonna make you an actual good game. It's gonna make you like. I'm trying not to say like any curse right now. This is a family-friendly server, guys. Come on, no cursing. Ooh, how do I say this? So imagine you go into a trash can, and like, oh my god, I forgot. It was a stupid thing. I don't know. It sounded like online where like there was like a barber shop, and like there was a trash can, and someone went there to like get hair because they were bald, but then they realized it's actually from a store nearby, which was like removing feet hair and throwing it out. And they just had feet hair. Like, no, I'm pretty sure they were trying to get it for a mustache. So like they had someone's feet hair in their mustache whenever they thought it was from barbershop. Still kind of weird if it was just from the barbershop, but that was funny. So yeah, that's pretty much. You think it's gonna give you something good, but it's really just you're gonna get something really bad. But all it can do is simple instructions that you give it, okay? And even AI, okay, AI doesn't actually. It's not gonna actually do stuff for you because I mean it's gonna do it because if you use it correctly, but if you just tell it, it's not gonna do it. You have to access it with input, give it to this guy. This guy needs to access like different like I don't know databases, online, whatever. It just goes anywhere, just anywhere, and then it gives output, which is your screen. It just gives it over here. And it does kinda save the conversation, so it does have like a I don't know how to say this, like I'd say like I don't want to say dinosaur, I'd say more of a brain. I just call it brain. It just saves all of this stuff. I'm not sure if it saves from looking online. Probably it does, but whatever it outputs is gonna save it. So whenever you input it, it can access the brain, and then it can access the thing. That looks really messy. But you understand. So I feel like I'm gonna sneeze. I'm sorry if I will. So they do nothing, and they only will follow instructions exactly as it's written. By the way, so if you write if I don't know a is equals okay, I'm not gonna actually write. I guess you guys don't know what I'm doing. So if you like tell it that if something, actually I'm just gonna if I don't know, you have 3 apples, and exactly like you just say if it has 3 apples, let through Okay, so here's the funny thing. So if someone comes with one apple, you know, they're not gonna get truth. If someone came with three apples, oh, three apples, they are gonna let them truth. But if someone comes with like 4 apples, they're not gonna let truth. But if they just remove one, we're gonna have three. They're the truth. Like they can hide it. They can like I don't know, throw it across the thing, show them three, and then it's gonna let them truth. So it's really looking at 3. So if it has 3 apples, okay, 4, it's not 3, which means it's not gonna do it. Now if you were like, if it has 3 or more, I'm gonna use this as or. That's not what I'm trying to type. Not or. I mean or more. And then this 4 right here. Can I get an eraser? What's the eraser? Is it E? It's E. Why is the eraser so thin? And if I change it, it's gonna change the brush. I don't wanna do all that. Too much work. That's gonna let them go. Truth. But 1 is required if it's 3 or less. So it follows exact instructions. Now, here's the thing. I need to actually tell you this before you actually start trying to tell your computer what to do. Oh god. One second, let me actually get an image of this. One second, I gotta show this. One second, I gotta show this. I gotta show this. Where is this stupid? Oh my god. Okay, once I have to look it up real quick. Oh, is it actually just called? Sorry, if it's called just machine code, I'm gonna cry. Let me check. Yes, it is. It is. So if you try to let me just hit this one. So if you ever try to like this, if you try to tell something, you have to write it in this. This is the language. It has some letters. I'm not sure what's. Is it? Does it actually have letters? I'm not even sure. I think it actually might. I'm not even sure if it does. I think it does. Wait, no, it does. It does. It does. But let me give. Yeah, it's fine. Yeah. Yep. Let me paste it back. So this is what you have to write for computer to understand what you're writing. But here's the problem. You don't know what any of this is. You like even I. If I'm gonna look at this, I'm gonna be like, yeah, no, I know what all of this is. Who do you think I am? Did I'm like Einstein? Like, huh? So here's the thing. Okay, instead of having to write all of like this, all the zeros, ones, the numbers and letters, you know, all of the weird stuff, there's something called. I'm gonna make it in like green, the size of a 10. Ew, this looks really weird, but I'm not writing it this big ever. There's something called code. Let me go back to 3. There's something called code. Now, what is a code? Okay, coding, code, programming, language, program, you know, all of that stuff. What is this? Now, I would explain it as, let me just think of a really easy explanation. So, you know how there is, and there's a world. So, let me just draw a, let me just, actually, yeah, let me make it like whatever. This now, can I make a circle? Close enough. So there's like it's gonna be a really bad world, by the way. So I'm sorry, but it's close enough. The way, and then we have like bam. We're just gonna bam, and then we're gonna just wait, no, it actually goes like all the way over here. Bam, and then we have like bam, whatever, good enough. Stupid gaps. Oh my god, stupid gaps, go away. What? How many gaps are there? Thank you. I'm gonna start tweaking out because there's just gaps everywhere, and it's just like, it just sees a gap and it's, so there's a world, right? This looks close to like a world. We have United States with Canada, all the actually wait, there's a wait, no wait, this whatever. And like, every different world has different languages. We have no, we have let me write in white. Nope. English, that's what we're looking at. We have English, we have French, Spanish, German. Why is my mouse being like this? It like stops writing for a second, it's weird. Like, all of those languages, right? But here's the thing, how would you understand, like, if you were to go right now, if you're in America, right? Like, I don't know, let's say you're in, like, Florida, right? And then you decide to travel all the way to, let's say, Germany. So, you, English speaking, trying to speak to a German speaking, right? Now, how would you be able to tell? Now, there's something called, let me get blue, a translator, okay? That's right. So let's say you're trying to say, thanks in English, right? And this guy, if you're just gonna say thanks, and like try to say it to this guy, he's gonna be like, huh? What are you trying to tell me? This is exactly what the computer is gonna. If you're gonna write, instead of the 1100 with like the weird number binary code, if you're gonna write something instead of that, so imagine there's you, so there's you, this the computer. It's gonna be like, it's gonna receive it and it's gonna be like, what do you want me to do? Like, what are you writing here? So this is why we have translators or programming languages, which it gives, or like in the real world you ask thanks, goes to the translator, translates it into danke, I'm not sure how to pronounce it, and he's like, yes, I don't know, I know what the reaction to this is. But it's gonna give some type of dialogue, some type of reaction that looks like Brad. Same thing works with if you were to erase this and type it like you, and then take this and type with computer, and then take this and then write it with whatever. I'm just type it code. No, I'm not really coding. I'm just write programming language. Whatever. I'm just gonna call program. Call close enough. So you write a specific code. Like, I don't know. Let me just write one like up. I'm not even gonna write one actually. I'm just gonna write like if 3 is equals to 2. It's not. It is not a proper way, but close enough. So you write this, it goes over here, then converts it to like, this is not an actual code, I'm just gonna write a random one. This should be, yeah. It's gonna convert that, and it's gonna give it to computer, and then it's gonna like sees it, and it's gonna be like, yeah, I can actually understand this. So that's what programming language is. Let's get out of all of this. Almost done. You just stay patient. Just stay patient with me. Oh my god. Okay. Oop. Oh my god. Thank you. Anyways, that is what programming language is. The computer. What does it say? The computer needs a translator. Otherwise, it will not understand you. Hold on, let me just take a sip real quick. Speaking so much makes your mouth dry, you know. So, here's the thing. There's two things. There is, in programming, there is, let me make it difficult. So we have compiler, and we have an interpreter. Let me just write it. Interpreter. Yo, I'm getting cooked tonight. I can't. It is not hard to say. Some component interpreter yo. One then. Yo. Yo, how do you pronounce interpreter?
Interpreter.
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 That is not. Okay, whatever. It's interpreter, and this is
Interpreter.
interpreter. Interpreter. Okay, now that I'm looking at the word, I can understand why it's interpreter, because we have interpreter. I know why. Interpreter. Interpreter. Okay, so compiler interpreter. So what is a compiler? So what it does is in a really simple like the most simplistic description. What it does is it takes a code. I'm just gonna make. It just takes this code, right, and it turns it, or like, quote unquote, translates it into a computer's language, which you know what that is. I'm just gonna write it binary. I'm just tired of writing this stuff. It turns into this, which is a runnable program, which means the computer will actually execute something. So it just translates it so you can actually use it. And it does all at once. Now, what does that mean? Actually, what does this mean? What does it mean is you have the code, right? Probably should tell you what it means by doing it once. I'm sorry. What it does is it takes all of this right now. It just takes all of this, just all of this. Straight up all of this, and it does it and it writes it into binary. Like it just straight up translates it. You know. Well, interpreter. God. Not that hard. It's not that hard. Just say it. Interpreter. Thank you. So what this does is it runs the program line by line, which means you have the program which is probably pretty sure it translate. It runs it. Okay, it runs it. The binary one, okay, it runs the binary one. It doesn't run the one that you did. The compiler translated it into the binary, so all of this is in binary, and this thing runs it. Okay, let me just make it green. It runs it line by line, and this is how your code works. It keeps reading it. It's running it line by line, and then you like get an error, and then everything goes kaboom, and remember, what was I gonna say? There's two things I wanted to say, and I kind of like messed this up because I was going here with an error, but then I also need to tell you this that the computer never runs the actual code; it runs the translated version. So compiler translates it, and then here's the code, and then the interpreter runs the translated code. But another thing is, you see how I said there's an error and then everything goes kaboom. Here's the thing: errors are actually really normal. Okay, if you don't get errors, you're either doing something really basic, and you can even get errors on the most basic stuff, so I don't know how you did that, or I was gonna say wasting time, but it's mostly because you're like typing too slowly and precise, but it's just normal. Okay, like errors are normalized. They're like the most normal stuff ever. What errors you are. So like, let me just remove this real quick. So let's talk about this actually, because it is such a weird thing that people are actually afraid of is errors. I think that makes people quit. I think that makes people afraid, and yes, all of that stuff. So what is error? Question mark. So error is pretty much computer. I'm gonna draw it really horribly again. So it's pretty much the computer. It looks like a microwave yet again. Perfect, just like I like it. It's telling you that I don't understand the code. Like whatever you just wrote to me, I don't know how to run it. And it's like it could be something simple as you missed the syntax. I think it spells with an H. Syntax. You missed like you wrote like and then you like typo. Then you get like oxidate 2 A's when it's supposed to be 1 A. You got something that was supposed to happen. You don't have like a save feature, so like it looks for something that doesn't exist, but it gets added later, but you don't have a save feature. All of that stuff, and like it runs and it's like I know what to do. So like you give someone nothing, told it to like so like imagine this. Okay, you work at a job. Or like you get a package. Let me get like brown. Okay, so you get like a package. That's quite a color. So there's a box. Okay, and like you get a package and you're like gonna deliver it to like you just gotta stock up some stuff. Okay, so you got like a shelf. You just gotta stock it up. Okay, and this pretty much your job. And so here's the thing. That's all you've been told. And so one day, there is just nothing. And like you gotta fill up the shelf, so like you're like, what do I do? Like there's no box. Where's the box? I need the box to fill up the shelf, but there is no box. So the computer in this scenario, and there's gonna be like 1 trillion different types of errors, but we're just gonna talk about this one. When there's nothing, it's like it's confused. What does it do? So what you do is over here, you tell them that you gotta stock up some stuff. But if there's nothing, just in case if there's nothing, just like rest, just like skip, like don't worry about it. So next time there's nothing, you're just like, okay, whatever, next, or like okay, and like yeah, I would just fine. I would just say like nothing's bad gonna happen. Yeah. So like computer just crashes out. That's what happens. It's like confused because computers don't know what they're doing. They just follow what you tell them to, and if you like didn't tell them something correctly, then they're like gonna like choke you or anything. Thankfully, I hope that's not gonna happen in the future. The AI just gonna like execute you for like writing the code incorrectly. In my notes, I have this little comment: computers are strict, humans are forgiving. So, human mistakes are allowed. Like computers, they don't make mistakes, and they do get kind of, not dependable. What's the word? Like, they like need the exact same code. Like they're like not needy. Actually, they are needy. Yeah, needy. They like get so needy when it comes to code. But humans, I mean, you tell them we have like 20 different ways of saying the same thing, and like you'd understand everything. Computers, nah, they're so needy. Now, let's start with the basics of. So to talk about the programming, like what is programming? So this pretty much programming is pretty much a instructions. You just write an instruction for the computer. It follows your instructions in its own language, because programming code works as a translator. It's like going to Germany, talking to a German using a translator. Okay, that's pretty much what it is. Except you actually give also instructions that he has to follow. So let's just say you're actually like a CEO of some company that also in Germany. You're going there and you're telling someone to like instructions of work. I don't know, just like make up something in your mind. So let's start with the first thing. It's something called running a program. Okay. I don't like my P. I don't like that. Good enough. Hitting green, good enough. So running a program. So how does a I'm sorry, I just had like a weird brain fart right now. How does a program execute? So a program, okay, it starts at one place, which is usually the top. So you have your script, right? I'm gonna just make it a box, okay? So this is a script, you know. Don't worry about what the script is. Pretty much your code. That's as basic as I'm gonna tell you this. A code. Or like where the code is. So you have, you know, the beginning. Then we have more stuff right here, visible, right? So we have just code, and then we have stuff right here, and like, you know, all that stuff. So what it does is it starts over here, right? So it starts like right here, so it starts here, okay? And then what it does is it does one line, then it does the next line, then it does the next line, then it does this huge line. Then imagine this a loop, which means it does this, then it does these lines, right? Let me just make it all one line, because simple. So it does this, then it does that, then it does this, then it's a loop, which means it does this again, then it does this again, and then it does it again, because it's a loop. Okay, so that's what a loop is, by the way. I'm gonna talk about it later, but for now, just so you know, loops, they'll loop a code. Okay, so as you can see, everything runs line by line. So first, second, third line, you know, it goes from the top to bottom. It never goes the other way. It always goes from the top. What loop does is once it reaches the end, if it's still true, if the loop is still active, it goes back to where the loop starts. So it runs the same thing multiple times. That's what it does. Okay. So it runs, and after the loop ended, it runs the other code, and then it reaches the end, and it just like stops because it's done. So that's how code execute. That's pretty much how programs work. I have a note here. The computer does not read code like a book. It follows it like a recipe. Again, yes, it doesn't skip steps unless it is told to. It's a special functions we're gonna talk about later. But for now, just know it doesn't skip steps. So it just goes from top to bottom, just top to bottom, just top to bottom, just top to bottom. You know, the only, I mean, technically it still doesn't skips the steps with special like functions, but it just breaks. Like there's a thing called break, and it breaks the loop. It just I'm not gonna write the whole thing, but it just breaks the loop. It just ends the loop. That's all it does. Like you can put in the middle here, and then after using it, the loop is just not using it, and it still goes the next one. Technically, it skipped like that one line, but but it also just kills the loop. So like the loop is not active anymore. So he just gets out of the loop. You know, it's like a weird way to say it. But and here's the funny thing. No, I'm not sure if many people know. Some people might think. The thing is, if you like start running a program, right, everything is like so fast, and you think that, but maybe it all runs like at the same time. Now I did tell you that it runs one by one, right? But it never actually runs. It runs really quickly. That's the thing. Like, it will read this entire loop in like less than a millisecond, most likely. It is this instant. The thing is, it always follows one by one. It doesn't run simultaneously. It doesn't. No. It doesn't run it all the same time. It runs it one by one. So remember, it's like weird things, but like, if you make an object at the top, just don't worry about like making an object. But I just need to tell you this: if you make an object at the top, and you call it in this line, it's gonna know it because it already happened. But if you try to find it, but you never actually found it, but you identified it here, it does know what to do because, you know, you identify it later. because it goes from the top to bottom, right. So like over here you don't identify nothing, so it goes over here, it tries to call it, there's nothing happening, and then it identifies it, but it's not gonna go back. It doesn't go back. It doesn't. So just go. Actually, no. Actually, this will give you an error. Wait. This right here would actually give you an error because it was gonna be like, what? What are you trying to do? What? But let's say that somehow it doesn't. It didn't, and it's just gonna continue on the other stuff, which is gonna be most likely wrong unless this is unimportant. So just gonna make sure you guys know that it doesn't run simultaneously. As in everything at the same time. Like the whole thing doesn't run at once. It goes step by step. So oh yeah, from the top to bottom. Yeah, and like as I explained, I had like not really a script, but like my little notes here, what I'm really gonna be talking about. It doesn't have like actual lines, but just what I'm gonna be talking about, what I'm gonna be explaining, and like yeah, flow changes whenever a decision happens, loop happens, or a function is called. Don't worry about these. I already told you a loop. It just loops the thing, and yeah, that's when it's like does not go one by. Okay, let me make it green so it's not scary. So loop is when it doesn't go normal one line. It just goes and then it loops around you until it is able to go down. But it's not really that. It doesn't look that different. It's really just if you need to use the same thing like multiple times. I don't know what I clicked. That was scary. But we're slowly coming to some fun stuff. We're done with running a program. We're done with talking about how a program runs. And time for... If you thought we're going to be talking about coding, you're wrong. We're going to be talking about input. And it's a really short one. I'm looking at it right now. It's like... How many lines is this? Like barely anything. Don't worry, this is going to be going... Or... We'll make it like and... I'm not going to put on like red. I'm going to put on like a blue output, okay? So, input and output. What is input and what is output? Now, if you remember from like couple minutes, probably not hours. Oh, actually, let me check my recording. I've been yapping for half an hour now. Okay. Now, if you remember a couple minutes ago, I was talking about, AI and stuff. How you get an input, it goes to AI, and then it finds something and goes to the output. So funny thing is, sorry. One second. I'm just gonna get some words up. How do I explain this properly? Okay. I got. So, you know how you're currently watching this, right? You're watching this. I hope you are. Well, actually, even if you're listening. I'm just thinking if I should color code it or not right now. I'm looking at that's like the main thing I'm thinking about right now. If should I color code it or if I should write it or if I should draw it. I'm gonna draw it because I'm an artist. So if you're listening to this right now, or no, if you're watching this, this is a monitor, okay? It looked so good for a second until I made whatever this is. What is this? So you have your monitor. Bam, 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 and bam. That looks horrible. That's not... No. Bam. A bit better. So, we have monitor, and then we have, whatever is going on. So, monitor, and then you might be listening this, you can hear me speaking, hopefully. So you have, that is a horrible... I'm just gonna keep it like this. Speaker, and then you have... Why, mouse? Calm down. I'm so sorry. I'm not a good artist. Headphones. No microphone. Microphone is not an output, but the microphone is actually an input. Okay, let me make it in green. See this? It's actually green because a microphone is an input. Okay. And let me just look. We have mouse. Keyboard. I'm not gonna make like a good looking keyboard. This is what I'm gonna do for keyboard. We have like Yo, this is this is a controller, okay? this is this is a controller. um, again, microphone. This is a weird microphone, but you you get my point. Um, what is this input? Touchscreen, okay. Which I'm actually gonna put right here. Or not really. I'm gonna make it like define your lines. So what this means is if it's touchscreen, okay, which means you can put a finger on it. Actually, I should just draw. That's a weird looking hand. Yo, I should never draw a hand. That's whatever. Which if we like get a hand here, so like I'll just make like this so it looks 3D-ish, not really. But if it's being touchscreened, it's an input because the way input and output works. Input is something you send data from. So you click a mouse, guess what? It sends data. You click a key, it sends data. I say data, but it just sends whatever it sends. Microphones, guess what? You speak into them and they input your voice. Their input, they put your voice in. Okay, put in, they put in. Output is they put out. Screen, your monitor, right? It puts out information. You type a key, it types it over here. You click, it like opens something. You speak, your friends, if you're in VC, they can hear it, or they speak and then you can hear it. Same with this game is playing, control, you click some buttons, the game's playing clicky clunky, you tap your touch screen, it like does stuff whatever you tap, it outputs on the screen. That's really what it is. It's it's really how input and output works. And then there's other types of inputs and outputs, but this is like an input and an output of a real life stuff. Okay, so this is like the most basic stuff. You technically kind of need to know this, but yeah, you kind of need to know this because output. But it's like really easy to remember. Whatever gives you data, it's output. Whatever you put data in, is an input. Keyboard, you click a button, it's an input. Monitor shows you stuff, it's output. Simple. Now, there's also another way, and it is the written one. I'll just remove this. Oh my god. So we have output. Okay, so let's talk about output in the like more of a coding terms. Okay, so output is when computer gives data to the user. So what happens to this computer? It gets data, from your code, and then it gives you the data, which it doesn't actually give you handed into your hands, but it'll put it like on the output devices, like the screen. If you have sound, speakers, all of that stuff. Pretty cool, am I right? But it gives you stuff like text, like printed text, messages, results, anything. Okay. Then we have our beloved input. I'm not even gonna write the thing. And it's pretty much when user gives stuff I probably should made it in green, the other user, but sorry. Computer. Okay. But really not really, because I'm gonna write this in yellow, because technically it's not. No, it's fine, never mind, I'm tweaking. And then so I had to I have to come down a bit from talking. Okay, now just gotta make sure I tell you this. Computers, okay. I haven't noticed this. They don't really gas. They cannot gas, but that's a lie. They can gas, not really. The way they can guess, if you give a math that's random, that's the only way they can guess. But if you don't have that, then okay, they cannot guess. input is how they receive information. If you give them a specific information, that's how they get it. Otherwise, they cannot just pull it out of nowhere. You have to give it that. Which actually, now that I think about the math, that random is also technically an input. So, yes, the input is how it receives information. It just cannot just pull up a random number. You just can't think like 3. So if you ask like x equals, ignore this for now. So like if you ask them this, it won't just go, well, 3 is equals to 3, so it's gonna like, yeah, no, it won't know this. You need to give it a number. Also, in some scenarios, which actually in most scenarios, whenever you ask for input, which is input as in, like, there's specific codes that allow you to input, as in you can type or do stuff, like actual, like in the console, for example, you can actually like type your response. The computer will wait. It's gonna patiently. It's gonna wait for your reply. So it's gonna wait till you actually write something, and then after you write, it's actually gonna continue executing the code. So if you have like your code, and then you have your input, then you have like your output right here. The moment it's gonna reach this, it's just gonna wait until you write something, and after you press enter, after you type it in, it's gonna go to the next thing. Just a quick note, it's usually in every input unless it's like from outside, like in the game or like something like that. Then you have to manually make a wait thing. But if it's in the code and you write a wait, not write a wait, if you in the code and you make like a input thing from a console, then it will run. Okay, now this is where it gets fun. I'm making it pink. Are you ready for this? Variables. I did not pronounce it correctly. Variables. Actually, no. I know. I just said variables. Okay, now, what is variable? What is a variable? Okay, variable. Huh. Variable. I cannot pronounce it correctly. I always keep saying it variable, but I don't know if that's correctly. So what is a variable? There's a lot of things that can like explain a variable. Maybe we'll just use it as a box. You have a box. That's a weird looking box. I'm never drawing a box ever again. And then it's open, right? And like here's the thing. You can like you can like put stuff into the box. You can like put like a number, a word, you can put like an object. You just put anything into this box, and on the side of the box there's like a number or like the name of it or like a name tag. So we have like a name tag, and then it says like meow. I don't know. I'm just making stuff up. This is really low quality. It has a meow. Yeah. It has it has text, and like anytime you gotta make sure it's at the top, so that whenever you're running at the bottom, because remember it goes from top to bottom. But every time you call it, it's gonna be like what is meow? It's gonna be like, oh, meow. Or, by the way, one really important part, you can write the exact name, okay? Remember, capitalization, everything matters. Everything. There's also stuff you can do, like I think, pretty sure you can put a number. It cannot start with a number. It can end with a number. It cannot start with a number. Pretty sure it's not supposed to have any symbols, no spaces. Okay, it has to be all in one word. And for example, let's say meow is 2, so it's gonna be like meow is 2. Okay, like imagine it had 2 in here. Just ignore these 2. But it had 2, and then it's gonna be like meow is 2. Okay, and like you can do like meow plus 3 is going to be what? It's going to be 5, because 2, so this is actually 2, plus 3 is 5. And then you can also stat it, so like you can be like meow is equals to, I'm just going to write in this, meow, which is also really 2 plus 3 is going to be 5, but then it's going to give this number to this guy, and then it's going to be like meow is 5, because it reset this thing. It does get confusing like this. I'm gonna talk about this whenever we're gonna get into actual thing, into like actual coding, but this in the basic variable. And here's another thing I'm gonna talk about more. And in a code, by the way, I just gotta tell you this, that whenever you're writing this, so for example, we have a variable, okay, let me remove the box. We're gonna write this in an actual code thing. We have a name, okay. We're gonna call this, but the name doesn't really matter. It is the name of it, and the only matters is when you're trying to call it. So make it reasonable that you can call it any time, but it doesn't have to be like. I mean, if you make it real, and it's gonna be fine, but it doesn't have to be. But it's gonna make it look better for other people and for yourself. So, but we're gonna use a simple X. By the way, a quick note: if you were in algebra, or if you're not in algebra yet, they are really similar. Algebra and coding are really similar. In a way, there's a lot of things that are really similar. You at least know that there's an if statement in algebra. If you've seen this thing, or like x equals, no, I think it was like this. It does this and that and this, and like, yeah, this thing, we have the ifs. We also have the for loops, which is this stupid thing, stupid. Then we have functions, which is, you're not gonna worry about these too much right now, because I'm gonna be talking about all this later, but I'm just showing you that all of these are really just the same. It's all the same. Actually, this is pretty much just a copy of this. It's just F. But all of this is really just the same. So X, and let's say, I'm gonna make it green. We're gonna write 3. What does this mean? Okay. So X is the name. That is the name that you're gonna be calling. So every time you're trying to do like math, you can do x plus 2, and it's gonna be like 5. Make sure that x and x, okay? If you write y plus 2, then it's gonna give you an error, because it's like, what? What is y? I don't know what is y. You never told me what y is. And like it is gonna like die. Then we have this. Okay. This is a really important thing, because as you saw, I previously, in a lot of stuff, I tried not to use equals as much, because you know how usually equals just means equal to, or equal to as in is, not really is, but isn't the same. And here it's different. But so 1 equals is literally mean, I think is, not, yeah, kind of is, but equals, not equals to, actually it is, it's pretty much is. And then 3 is a number. It's a number, it is the data, it is the value. Actually, I'm gonna type this as a value. It's a value. By the way, variables, in some codes, you are required to type a type of variable. In some codes, you're not. And in some codes, you have to change the variable type to give it some other type. In some codes, it doesn't matter. I'm not sure how, but it just doesn't. So that's really silly. Now, before we start that, I just need to again tell you this. equals this number right here, the equals this right here, this one, this equals sign right here, okay? Before we get too much into it, this pretty much means put this 3 inside x. So remember how this is a box? How we told you, I told that this is a box, right? It literally means put 3 inside this box. That's called x. That's literally what it means. Put inside a box and call it x. Or named x. It depends, because sometimes you have to actually specify in the beginning. Because here's the thing, in pretty much all languages you have to specify like local or like var or like int, you know, and then you can actually do, you can write it later and put like 2, and then this is put this value inside a box and call it into a box and call it x. And then over here it's gonna be like, okay, now put 2 inside the box. But here's the thing, the box can only hold 1 value, so it removes the other value. Now you have 2. So I'm gonna look if I talk about arrays. Yep, we do. That's gonna be later. So we only really talk about, or not talk about, we only have 1 space in there, so it takes the other one and it changes to this. And so I don't have to explain about the other stuff, but what is 2, it just pretty much means you remove everything previous and you put this into there, okay? So this x is going to be 2. It just removes everything. All of this is gone now because of this. This one changed the value of this. X is now 2. It forgets about 3 completely. It doesn't remember about it. Unless you have like another value over here being like, oh, not the same one, but y is equals to x. So like whenever it became x, it became y became x, and then it goes over here, and then you can still use y, but that's like, at this point just change this to y instead, and like have 3 and 2 or whatever. But remember, 1 equals is actually, it's not like mathematically it means like equally, like equal, like and 3 is equals to 2. It's not, that's false. I don't know what I was trying to do here, but yeah, it is not false. It does not mean this. It means put 3 inside the x. You know, set x value to 3. Which, if you really close it kind of does mean it, because like if you look at this, then you can easily tell that x equals to 3 if you look at this, right? So, you know, whenever you do math, like 2 plus 5 equals x, or actually no, 5 minus 2 equals x, you know, so you like subtract, and then we have this, and you can easily tell that x is equals to 3. Yeah, in a way. Again, algebra, really similar. But here's the funny thing. Remember how I told you, how in some scenarios you have to specify types? What is a type? A type is, how do I explain it? So in some cases, variables, so we have x, can only have 1 type, which if it's a number, it's gonna only have a number, which means it can't have words. So it has to choose one, either this or this. It can't have both. It has to choose either. You can, in the future, you can change the data type, but before they have to specify. If you put int, it's gonna do integer. If you put string, it makes it words, only words. And if you try to put a number into a string without quotation marks, it's gonna think you try to put a number inside the string, and it's gonna be like, no, can't do that, error. You're gonna get executed. No, you're not gonna get executed, but you know, It's not gonna like that. So pretty much, it's just not gonna like that. Now, what I have written here is 4 really basic types. For some reason, I have one of them decimal. Why? I don't know what's going on there. Maybe I forgot. So we have integer. I think in every programming language, it is known as int. Int. What is integer? Integer is a number without as like leftovers. So 2, -1, 3. It cannot be -2.5, 3.14 pi. It cannot be pi. If it tries to, in some languages, some stuff, it just removes these, and it just has this 2, 3. In here just removes the 5. It's just a -2. It just. So that's integer. Okay. Now we have float or double. What is float or double? Okay. This is pretty much just any number. Could be 2, could be 3.4. That's not a 4, that's a 1. 3.4, 5.7, 1,000. Doesn't matter. It's just, any number. And it can go to the negatives. It can also go to the negatives. Then we have our beloved string. It is pretty much words. Make sure it's in quotes. This is the only time you make sure, not the only time, but in this one you make sure it's in quotes. Okay? So it has to start and it has to end with quotes. So for example, hi. This is a string. 3. Okay. This is where it gets confusing. 3 could be a string and a number. This 3 can go to any of these. All of them can be 3. Here's the problem though. This is an integer, which means it can never go to the negatives, and it's a normal number you can use in math. This is double. It can go to the negatives in decimals. Wait, did I say negatives on this one? This can go negatives. Remember, integers can go negative, but it cannot go decimals. This one can go to decimals, and it can go to the negatives. It can do whatever. What is this? Can also be used in math. This one, no, you cannot use it in math. You cannot. This is not usable in math. This considers as a word, which you can combine these two to make it into a high 3 if you want to. But it is considered a word now. You cannot use it in math. You can make it decimal, but it's not gonna be used in math, so you can make it negative as well. Doesn't matter. It's not a number anymore. It's a word. And then we have like periods, commas, semicolons, columns. All of these are allowed. Quotation marks are not allowed, pretty sure, because it's gonna start tweaking out. You can use singles inside this thing. That's allowed. Or if you have this one isn't singles, you are allowed to use double, I think. But there's also special functions. For example, this makes it go to a new line. I forgot how to do a quotation mark. It's like quote. I don't know. I forgot. Don't ask me. I forgot. Or is it just Q? I don't know. Oh, those are spaces. Spaces also are allowed. This is just a space. This is just a space. Next, we have car. What is car? Car, or actually no. The full name is character. It is known in programming as car. Car or character is usually single quotes and it's just one symbol. 3 Y A B capitalized B. By the way, make sure all computers are cap sensitive. So okay, I'm gonna talk about it later, but everything is cap sensitive, which means B is not the same as this B. They're not the same because this is capitalized, this is lowercase. Same with strings. By is not the same as lowercase by because B is capitalized. It doesn't have to be the center layer, it could be the other layers. If it's not the same, it's not the same. You have to do special functions for that one. I don't know why I'm yelling. But yeah, we have character. Next is boolean. It also sometimes known as bool, depending on the language. It is simple. True or false. That's all. Just 1 or 0. True or false. That's all for the bool. It's only one of those two. These do not require quotes. True and false will all remember lowercase. Has to be lowercase. These two will always be. Who's texting me on Outlook? It has to be lowercase and it has to be written exactly like this. Either true or false. Next we have yes. You can call it void. You never actually use it. In Lua you can. It's you don't have to specify which type, so you can use void, but void is pretty much nothing. And I don't think it's actually the official. I just say this as void because I want to put this value into this. Because I have no idea how to else put it. I'm gonna call this void. Void in a lot of stuff, if you look at like C++, C#, void is gonna be something that doesn't return a value. But you know what else that is? Nil or null, depending on the language you are using. I'm not sure if there's another one. And it's pretty much equals to no value. In Lua, for example, you don't need to specify. You can just write like x local x is equals to nil, and like it works. And then you can like make x equals to 2 or like x equals to high. It works. I think in Java, yeah, pretty sure in Java, I'm not sure if a type matters, but you can put null into any type, and it pretty much makes it so that X is like, it doesn't have anything yet, so it doesn't put like any garbage into it, or like it doesn't like tweak out whenever it sees this, or is it C++? I forget which one. So that are the types. And remember, one of the most important stuff probably one of the most important one. These three numbers are different. These are technically kind of the same, but except one of them allows them to go into decimal, another one doesn't. This is just another value. This is another value. In a way. In a way, by the way. This is a character, this is a string. I should know. I should think they would be in some scenarios same, but in some scenarios I don't think they are. Need more research on that one actually. I never really used a string with a character before. I don't know. I actually never really used character that much. I don't know. I don't use it that much. But these are the types. So now you know that there are quite a bit of types. and they kind of matter. In some languages that they don't. Anyway, they always matter. They always matter. I meant as in specifying them, but they matter. Remember, you cannot compare 3 to a string. That's a weird string. You cannot compare 3 to a string. You cannot do that. That's going to give you an error. Or like anything like this. And now here's a funny thing. Going to the next thing, another important thing is operators. Now operators are going to be useful for the next stuff I'm going to be talking about, and one of them is okay, no, actually I'm not going to tell you yet. It's going to be a secret for the next one because that's literally going to be after this. I love keeping people on their toes. Not really. But first we have our stuff, basic stuff. Okay, we're gonna call this math. Basic math operators. We have what? Minus, multiplied, division, percentage, plus, all that stuff. In coding, minus is minus. X is the little star symbol. It's above 8, so you hold shift and press 8. Division is a slash. Percentage is a percentage. Percentage is I forgot what it's called. I forgot what's the actual code. It's called can you just get a name? Modulus. It's called modulus. First, she's gonna see if like it has a remainder or not. You know, if it's divided with a remainder. Actually, I'm pretty sure it just gives you a remainder. I forgot. Then we have plus. That's just plus. That's pretty much all for the math ones. Now, important one. Okay. Let me write comparisons. This is the thing that you compare stuff with. We have equals, negative, that's not negative. One on my own. Exclamation mark, equals, less than, more than, less than or equals to, and more than or equals to. Okay. I love how my thing has them in whatever. You write this as equals to, and by the way, these are not the same, okay? These are not the same. This one sets thing. This is a setter. It sets x, sets to 2. This one compares if x is equals to 2. This one sets x to equals to 2. This one wonders if x is equals to 2, okay? Make sure you know this. Then we have exclamation mark equals to, which just pretty much means not. Or not equals to. But it is written as this. Pretty much not equals to. Or actually, exclamation mark exists by itself. You can put it before something like. Or I mean, it's gonna check. It's gonna be like, if it's not equals to 2, you know. Then we have less than, which is if it's less than 2. Then we have more than. This one is like reading like this. So like, if it's less than or equals to, if it's more than or equals to. So you have to know what these are, man. Like, if x is 1, it's gonna be true. If it's 2, it's gonna be false. This one is true, 2 is true, 3 is false. You know, cool stuff like that. I don't have to explain this too much. Equals, one singular equals is storing, 2 is comparing. Just make sure you know that one. That one is important. And then we have logical. I'm kind of speeding through this because there's just basic stuff. We have and, or, and not. And by the way, not is the exclamation mark, But it also depends on the language. Okay, so this works. This is true. Yes, I'm not sure, but I think it's some. I think Lua has this one. But by the way, here's the thing. It depends on the language. But anyway, back to the thing. I forgot what I was doing. Oh yeah. So we have end, and end is pretty much into. Okay, going back to the thing because I got distracted. We have like and, we have or, and we have not. And the and, it also depends on the language you are using. So and could be possibly. It's in some languages it is 2 of the. If you look above 7, you'll see the weird looking whatever it's. I'm not sure how to explain it. It's and. It is and. It's a symbol for and, but you need 2 of those. In some for or you type 2 sticks. It is above the slash. This slash, not this one. That slash. You need to write 2 of this for that one, not this exclamation mark. But in some languages you can still use those. Some languages you have to use those. Depends. And then we have 2 of those. It depends on language. I think Law uses this one if I'm correct. If I'm not wrong, I'm wrong. Pretty sure it used that one. We'll see. That one is all for that one. And now we're moving on to the next one. And that is... Oh, I accidentally removed this thing. Okay. Decisions, my favorite, not really. Decisions. So, what is a decision? Decision is if statements. This is what makes your code. You're gonna be using ifs a lot. This pretty much. It's an if statement, bro. It's literally just. If x equals, it's literally just a check. You gotta make sure everything works properly. It outputs a true or false. It really just outputs that. We're gonna get into this in the coding stuff, but I'm just explaining the basic stuff. Like, it just checks if stuff are true, and then it's gonna like run the code. And then there's also another thing. Else, if, or sometimes some codes have elif, mostly Python. I hate Python. And then it is pretty much if you want to put another check into this. So like if it's 2, then it's gonna do this code. If it's not 2, it's gonna do else if. Then if that's not true, it's just gonna, you can write else, and then you can write a code for if it's not 3. If it's neither of those 2, and you don't have this, it's just gonna continue the code normally, but you can have an else. It is not required, but it's just really good to have. It's actually like literally that's pretty much all for decisions. It's really just an if checker. It's literally just checks if something is this, then do this. Else it's not this, it's do this. If it's not, then just do this. If it's neither of these 2 choices, it's simple. Next we have loops. My guns feel weird. Like really weird. Might just be good. So let's go to loops. Our favorite cute little loops. I'm gonna make it in a nice cyan color. Loops. That's weird ass. Why do I keep making what? That's the what? Good enough. I think it's the P that makes my ass look weird. Let me just. Whatever. Oh, okay, so loops. Remember how I talked about code that runs itself over and over until it decides to go? That's a loop. I'm sorry, I gotta get some water. My gum is just feeling really weird right now. I'm sorry. Also, my not lip, my cheek is a bit in it today as I was eating. That's not fun. Um, but anyway, back to our thing. Loops is pretty much. There's multiple loops, by the way. Most known one are three. We have the for. That's not how you. We have the for loop, the while loop, and then the one that changes depending on the code. We have do, while, and then repeat until. These two are the same thing, they just depending on the code, programming language, you'll have to use one of those two. The one the until has to go on the separate line, by the way. You can put a code here and then keep it like this if it's really short, but other than that, you just, yeah. So let's talk about for loop. What's for loop? It's pretty much used for counting stuff. If you have something that you want to count how many times something happened, or if you want to do it a specific amount of times, if what did I do? Or like you have to go through like an array. You know what this is, but it's pretty much a variable that has multiple values in it. Use the for loop. So also it could be, so how to make a count, we can do something like this. So it starts with 1 and I is 10 and then I plus plus. But wait a minute, so there's a syntax, don't worry about those. And then you know what this is, you know that it sets it to 1. Okay, so it creates a variable that's called I, which we call it index, but it's really just I. And it sets it to 1. But then, if it's if the I is equals to or below 10, it's gonna run the loop. But what is I plus plus? Well, glad you asked, and I know you didn't, so I have to do it for you. So plus plus as well as minus minus is pretty much take the variable and add 1 to it, or take a variable and remove 1 for it. But here's a funny thing. Oh no, so it's also gonna set it to this, but the funny thing, this is this. So a lot of people would get confused, but it's really simple. It really comes to printing, which it's gonna be enough. So print, I'm not gonna be talking about it right now because it's different in everything, but pretty much just gives you the information in the console log. Now print, if you print this right here, it's gonna print you the, so for example, let's say var, all of these have the same variable, right? It's equals to 1. If we put this one, it's gonna print 1. So actually let me move this. So var is equals to 1, okay? So if we do this one, it's gonna print 1 and then it's gonna add 1. So variable is gonna be equals to 2. So it's gonna print 1, but then it's gonna add, okay? If you put it the opposite way, then it's gonna add 1, which means it's gonna print 2. It is the order, okay? So in here it prints 1, then it adds, then it prints. It prints, then it removes, then it prints. Just a quick note on this. So from this we can understand that this will for loop, in some languages you have to do this pretty much start of the code and then the end of the code. In Lua you have to do and, but then all of this is going to be wrong, so I'm writing this more in a format of other code. And then we have a code here that's going to do 1, oh god, it's gonna do 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And then it will continue its life. You can also put break to completely break this, and then so like if you want to do like I is equals to, you know, to it's gonna break, you know, it will work. It's just gonna remove this for loop completely. Or if you have like some code here and like you want to make it that if I is equals to 2, it will return. What it's gonna do is it's gonna stop this code completely. So it's gonna go right here, and then it's gonna loop. It's not gonna run this code below it. So return is pretty much ends the loop. Break breaks the loop. And by ending the loop, I mean it's gonna end this one loop and then it's gonna do another one. So pretty easy, pretty easy. And it really just does this until it becomes false. So until it's not below 10, it's gonna do it. And same with while. So while is pretty much you put a while, you put a value. It's gonna run this until it's not 2. The only problem is, unless you don't have anything changing this to 2, it's gonna run this completely infinite times. It's gonna run it infinite times. And then if you have nothing that stops it, your program crashes. Another problem. The computer executes codes really fast. If you have something that is infinite looped and it doesn't have any wait, anything that makes it wait, it's gonna keep doing it infinitely for like a really fast times, and then it's gonna overwork like the computer, the program itself, and it's just gonna like, it's not gonna explode, but your program's gonna die. You have to close it. In some scenarios, they actually now warn you about it, and in some scenarios, they will actually stop it if it's doing it too fast and too much. So if they see that it's infinite yield, they're just gonna stop this. They're just gonna stop the loop, so it doesn't like kill your program, which is good. Just make sure you might lose some progress if you're doing something that's doesn't stop your loops. Now, let's go back to the if statements, but more into an if statement's brother. We call them switch. Okay, now what is a switch? A switch is pretty much, in some cases you just type switch and you put a value here, which is, we're gonna go with I. Okay. Okay. And then we go like, man, okay. And then switch. Oh my god, I forgot the next one. 1 second. Let me see this real quick. What's the other one? Case. It's case. I keep forgetting case. It's case. So case, and then let's just say 1. It's on actual code. I don't know what I'm doing. Is it default? I'm just putting default. I hope this is correct. Doesn't even need a break. Okay. Now, you look at this and probably like, what am I looking at? Good question. So let's say, okay, actually it's easy if it's 1, if it's 2, right? Let me just tell you this first. Okay, this number right here, it cannot be decimals. And if I'm not wrong, it cannot be strings. It can be, so it cannot be decimals or strings. It just cannot be, but it should be, it will allow you to have normal numbers. It should allow you to have true or false. it should allow you to have characters. Perfect. Now that I specify that, you know what to put there, what not to put there. Now, as you can see, there's quite something, okay? And yes, you need to put columns in here. And why does this one have a break and this one doesn't have a break? So, funny thing, okay? So, number one, if the I is gonna be 2, it's gonna run this, right? It's gonna run this, and it's gonna stop the switch. Simple enough. If it's gonna be like 3, it's gonna go to default, because, you know, default is everything that is not one of these two. It's gonna go to default, it's gonna run this one code. But here's the thing, what if it's 1? What if it is 1? You know, the 1. I have no idea why I'm trying to make it look more higher quality the more I write it, but anyway, here's a funny thing. What it's gonna do is it's gonna run this code, right? It's gonna run this code. See my thing, okay? So it's gonna end. No, it's not. It's gonna go to the case 2, so it's gonna go to the next one. It's gonna run this code, and then it's gonna break. Could be useful in some scenarios. For example, if you want, like one of my professors explained it, but I'm gonna re-explain it in a different way. Actually, never mind. I'm gonna explain the same thing. It's like a membership thing. So we have, let's say we have gold, silver, and bronze. So bronze get like ability to go to the toilets in the facility. This one gets ability to get free lunch. And then this one gets the ability to a free spa salon, Not gonna lie, it's pretty good. No, here's the thing. Bronze, of course, he'll only get the toilets, okay? He will not get over there. So he's not gonna be able to do this. But silver. You want silver to be able to get free lunch, and you want the silver to be able to use toilets. And for gold, you want to use spa, you want to use free lunch, and you want to use the free toilets as well. Silver cannot use the spa. So what it does is, for example, this is gold, this is silver, right? Ignore the D. Actually, nah. So let's say this is gold, this is silver. Ignore bronze. Who cares about bronze? So this is allows you to use, spa. But here's the thing. This one right here. So this is the lunch, right? This is the code for lunch. This is the code for spa. Don't ask why this one is 2 lines. It's gonna run this, and then it's gonna go to this one. So it'll have both of these. Silver, on the other hand, will not get spa because it goes down and then it breaks. So you have something like this. In a way, it's easy, but in a way, it's kind of weird and hard, depending on if you get me or not with my stupid accent. I'm so chapped. But that's pretty much the switch statements. Now, I've been speaking for 1 hour and 34 minutes. Some apologies, but I'm trying to cover like the whole basics in like one video. So hopefully it's gonna be quick enough. So let me get a sip real quick, okay? There have been people messaging me. Really hope it's not important. Anyway, okay, I'm about to show you something that I actually had problems the first time learning, and I wish somebody would told me this sooner. This is a functions. These are functions, okay? So what is a function, okay? I mean, you see the analogy, right? It's like a function, they give you like, f, x, equals 3 plus 2, and they ask you like, what if x is equals to 2, or like the x inside the thing, the fx x. I'm not sure how to make this math problem balance, but like pretty much what it does is this one is going to be 2, and then uh this is not true. Wait, this is this isn't quite true. Wait, okay, whatever. But you get my point, okay? What it does, a function is a silly thing. It is a code. So let's say we have a function. There are like different ways of making a function. It's different every single programming language. You have to look at the syntaxes and stuff. But we're just gonna put function, and then I'm gonna put a name. So let's give this name horse. No particular reason, just horse. I don't care. We type parentheses, which is parameters. Okay. Again, some places you're required to put a type, some places you don't require to put a type. We're gonna put a, and we're gonna put a b. In fact, it looks exactly like Lua, so I'm gonna write it in a Lua way. And ignore this. This is pretty much the same as this, just different syntax. So and let's say that a plus b. No, actually, if a is more or equals to 1, and then we're gonna do else here, okay? We're actually gonna do some type of in a way coding. And then we have another end. I was kind of messed up here real quick, 1 second. Forgot, if I'm gonna make it more in a Lua way, gotta put then. Okay. So, and it's gonna return a plus b, and then over here it's gonna return a multiplied by b. Okay, okay. Now, looking at this, you might be looking at this and be like, okay, so no, actually, before that, actually, let me show. Okay, let me actually, before I even explain anything, just ignore this real quick. Just ignore what's written there. So there's a code in here, right? A function is pretty much a block of. So this inside this, it's called a block, by the way. Well, so like, and the same goes with if statements. This is a block. Same goes with loops. Whatever inside the thing, it's called a block. Okay, so function is a block of code that you can use anytime. Pretty much, if you just have the same thing repeating, if the same code, instead of making like same lines, you can just make one line, just call it with like a simple like word, like phrase. And it's also like really good for readability, but it's really good for making sure you don't repeat the same code over and over and over again. Now here's the thing. There's two things. There's parameters and there's arguments. Let me write something here, okay? Oh, actually, let me just local. Gonna do this meow equals to 2. Then we're gonna have local bark equals to 3. Okay. Actually, let me just remove this real quick. So let me just make it blank. I'm too lazy to erase it. But and then let's do horse. Meow bark. Now it's actually not gonna do anything, but let's just say in here it has a print command. Just don't worry about it. Let's just say it's gonna print on console log, but we're not gonna put it here. But imagine it prints it somewhere, it does something with it, shows us the number, okay? Because if you're just gonna put it, it's not gonna do anything, because it really just gives it the value. But it actually doesn't with one. Okay, let me make it easier to actually understand this. I'm gonna do this flower, and then we're gonna make it horse, meow, bark. I don't know. Never mind. Okay, so okay, we don't need a print for this. So this one is will actually do something, and actually, not just so people just won't get annoyed if you didn't know what to do. Oh, here you go, happy. So that's quite some code. There's actually a working code. Should be a working code, unless I somehow messed up something. But if you look over here, you see quite a bit of stuff, and you might be confused. Now, I know that there is a huge questionable thing over here, and then there is this, and then there is all of this. And okay, let me explain this for you. Okay, number one, parameters versus arguments. This is a parameter. This is an argument. P, A. Okay. Now, what is a P? What is an A? Okay, parameter is an expected. It says input, but I can add the input value, so it is an expected input. Okay, expected value. And sometimes you have to actually specify if it's like an integer or string, but in Lua you don't. And it's, as you can see, they don't need to be the same. Because here's the thing, meow is, actually it's unknown here, but let's say it's 2, this is 3, which means this is going to be 2, this is going to be 3, doesn't matter. It's just the A is not going to be 2, and B is going to be 3. Pretty much that's all. This is pretty much the same as, literally the same as A equals to meow, okay? Which means it's going to be this 2, this is nothing because it doesn't have anything, but it's going to give it 2, so it's going to be A is literally the same as 2, okay? Simple as that. Done. So if you look over here, if A is more than or equals to 1, and let's say meow is 2, so it is going to be 2 because A is going to be 2, then what it's going to do is it's going to return A plus B, which is 2 plus 3 is 5. It's going to return it. I never knew what was returning from the tutorials until somebody actually explained. So return, actually, if you are in school learning about this, you'll easily know what it is. I was learning myself, I didn't know what it was, because a lot of people thought it was normal, but it was kind of confusing in a way, because technically, you can do it without this in a way, and that's what makes it really weird. Because this right here, okay, this is useless, really. Like, you can just put it into here. You can put this print into here. You can, instead of putting this, you can just put print A, B, A plus B. Boom. Same thing. Same thing as whatever happened here, except this one now stores something, but you know. But return is pretty much, yes, you return a value, okay? You give the values and you expect to receive something in return. In some languages, return is actually like mandatory unless you make it a void, which is requires no input, no value. So as you know, void is nothing, null, and it doesn't require anything, which means it doesn't need a return. I'm not sure you can still use a return. Not sure if it's gonna get any value, but you can use return to end the thing, like a for loop, or I think the function. The function I think ends with a return. Yes, it does. I'm stupid. Yes, it does. Function ends with a return, which means you can end the code with a return in a void, but you cannot return a value, okay? You can just say return, and it's gonna end it. And if you use a value, it's gonna end the code, and it's gonna give the value to this variable right here. Simple. And then this is just print, okay? Now let's just say it was 1. So it is not 1, 0. It's below 1. Okay, it has to be below 1. And let's say it's 0. So it's not gonna be this, which means it has to go else. And it's gonna do A multiplied by B. Okay. And that is gonna be 0 times 3, that's gonna be 0. I forgot what I forgot what I said. Meow is. Yeah, it's gonna be 0. So it's gonna be 0. It's gonna print 0. Okay. If it's gonna be string, you're cooked. Because this doesn't tell what it is, it's gonna be, let's say we have B, this 3, okay? Actually, I think it'll just die on this one. It's gonna give you an error this one, because a character, or actually another character, a string, cannot be compared to a number. So it's gonna like give you an error. But that is really a function. Just know whether return. Like, I get confused with it because I was like, I did not have anyone teach me this. I was learning myself, watching YouTube videos, you know, all that stuff. But one guy said that's like a calculator. You like functions like a calculator. You give it values, it does the math, and it returns you the value. So, really simple. And yes, you are required to give it numbers whenever you call it, and you can use you can call it anytime, many times you want. So you can put like 10 horse with different values. It's gonna give you. It's pretty much reusable code. What it is. Also, there's something called scopes. Just a quick note, scope. It's like a really weird. So you remember blocks of code, right? Remember how I told you a block of code? So everything, while, for, functions, even ifs are not quiet. Actually, ifs are not quiet. They are in a way, but they're actually I'm tweaking. I'm actually tweaking. One second. No. If is. Never mind. Forget what I just said. If is actually also part of the code. In block, and then even the script itself is a block of code. Let me show you this. First, we have the script. This is the script block. It has all the code in here, right? Let me just type local x equals to 2. Okay. Then let's say we have like some other block. I don't care if it's for loop, while loop. Then we have inside like an if statement. Then we have another for loop. And then here we have, no, actually not even here. Let me just put it here. Local y equals to 1. Okay. This is important. Here's a funny thing. But before I continue, functions, by the way, can be put anywhere. They can put up top, or they can be put at the bottom. They will always find those. I don't know why they're being like this. Usually, me personally, I put it on top, but you can put it below, and pretty sure it should work as well. I put it on top. I don't know. That's just what I'm used to. Pretty sure you can skip them at the bottom. So scopes, okay. We have a block, we have another block inside, then we have another block, and then we have another block. This is the main script block. And then we have like, I don't know, let's just say we have like an while like going into like a if, and then we have like a for loop. Okay. And by the way, for loop actually creates an I. So that's funny. Here's a funny thing about scopes. So let's start with normal x. So if I were to type, if I want to print an x, let me write it in a different color, like right here. If I want to print in here, it will in fact work. It was gonna print. I'm not gonna write the code about printing x. It's gonna print 2. Okay. Right here, print 2. Right here, it's gonna print 2. Okay. So. And I can also do something. I can do x plus 1 or like I. It will work. It's gonna be like, how much is 1? It's gonna be 3. If I try over here, I can do x plus y. You know, it's 1, and it's also gonna be 3. You know. But this is where it gets funny. What if I want to print y here? Well, number one, it is before the y was even, you know, set before it was created, so it's gonna give you an error. Sure, let's try it, right here. It's later, right? So will it work? No. This is scoping, okay? The way this code works, or like the values, they can only go inside the block, so they can only be in their block and inside. They cannot go outside their little cages. They can go deeper in their cages, but they can't go outside their little cages. Which means y, this y, can be called in here, can be called in its block, but it cannot. It just cannot be called in the other box. It just cannot. And this I, it can only be called here. You can only work with this in this for loop, in the for loop in general. You cannot put into an if statement, unless you make another if statement here and then check it. But that's another if statement, it has another block. But wait a minute, what if? So this is where it gets funny, okay? Ready? So I'm gonna do is I'm gonna get an eraser real quick. Oh, you are going to love this. Local y equals to 3, okay. Okay, ignore this while, okay? I know it's weird, but let me just make this so it's not confusing. Let's say I want to print y here, y here, and then I want to print y here, and then I want to print one right here. Okay, so think about it right now. Which values is going to print what number? The first one is going to print 3. Okay, correct. If you think that this one is going to be printing 1, you are also correct. Now what about this value? As you can see, it's outside the scope, but it still prints 1. Why does it print 1? Well, it's outside the scope, so why does it print 1? Here's the thing. Creating a variable, it will make it have a scope. If you just replace the number, it's not going to change the scope. It still knows the variable. It just changed the number, and it's like, sure, it changed the number. Like, it's gonna be 1. There's also 1 because it changed the number. Now, of course, if this if never ran, if it was false, then these two numbers are gonna be 3, because this one never ran, which means it would never change this number. This one never ran because it never ran this wall block, and then it was 3. But let's say it did run, then it is going to be 1 and then 1 because it did change the number. So it's really weird, but this is how it works. Okay. Same things with functions and stuff. If you create a variable in a function, including its little that's weird. Including its little like variables like in this variables, these will not be able to. You can access this outside the function. These are inside the function. Everything in these parentheses is only for the function, okay? If you create something inside the parentheses of like for loop function, it's gonna be inside that block. Just remember that. So we got this, we got that, and time for the next contestant. I don't know if I can call these contestants. Well, let me see this. Debugging. I'm going to give it a golden color. It's not really golden, but it's yellow, but a lot of people are think it's a nuisance of a thing to do. It can be, depending on how bad it is, but I'm just gonna say what I have written here. What's a good stretch? Good programmers do not avoid bugs, they locate them. Oh, this is so wise. Whatever. Yeah. So again, as I said before, errors are common. They're like everybody gets them. You just gotta know how to find them. Okay. There are three types of errors. Um, Syntax. It does not spell with an H. I'm just being stupid. Runtime and logic. Syntax is whenever grammar is broken. Um, Syntax is the same as you accidentally double tapped a, forgot this thing, um, accidentally wrote if with a capitalized when it's supposed to be lowercase. You know, stuff like that. Remember, it's case sensitive. Runtime, crash while running. Well, a lucky. Okay, I need to. Let me see example of runtime real quick. Oh, okay, yeah, never mind. So here's the funny thing. It happens whenever it's the program is running, but it finds error there. For example, there is a compiling error, which means whenever it's translating something, it can give you a syntax error, which is pretty much something misspelled and can't translate. Runtime, it runs the code, but it notices that there's a problem here as it's running the code. It's in, no, it's trying to like you're playing a game and then a character health goes all to zero and then they're gone from the game, but then it tries to detect them and it's like, I don't know what I'm detecting, and then it's like gives you runtime error. Then we have logic. Logic is wrong answer. Once I gotta search for an example real quick. I don't know. It says a logic error is a flaw in the program source code that causes to produce incorrect or unexpected results. I've never seen it. Hopefully I will never see it. It's pretty much wrong answer. So it somehow gives you a wrong answer. How? I don't know. I don't know. It just somehow does. That's really all about debugging. Just it's this one is literally just talks about three types of Go errors, and it helps you. Syntax, meaning you miswrote something. Runtime, you have something that whenever you're running the code, something happens that it goes kaboom. Logic means some things in the source going on that makes you have a wrong answer. Syntax happens when you're compiling, so the moment you start, the syntax will appear. If you're playing the game and then you get a runtime error, that means something's going on whenever you're playing a game. Okay, time for array. What is an array? Array is whenever you have a variable, but there's just so many numbers. Like you have so many different things you want to like store, and like you just don't know, like you don't want to write multiple things. What you do is that's not what you do. You do this one. You just make this squiggly brackets and you just type this in. The order does matter. And funny thing, okay, number one, one of the most important things, depending on the code, you gotta understand that either everything, or like not everything, but most things start with a zero, as in, okay, so this, okay, before this, well, let me just tell you what an index is. So remember the for loop, this for loop, and like the I is index, like it goes up. Index is pretty much the number that is connected to this one in the array, that is. In for loop, I don't think it's actually called an index, but we use it in Lua U as an index usually whenever we go through an array, and we also will use it in other codings, programming languages. But if you're doing a normal, I say normal, but let's just say you're doing, but this has to be equals. But if you're doing like a most, if you're using one of the most, or not one of the most, but like most of the programming languages, it will start with a 0, and they will have a specific number like this. So the first number is going to be 0. If you're using Lua, it starts with 1. Just gotta remember this, which means if you're trying to, now here's the thing, imagine you're trying to print an array. If you do this, I think in some times it will try to do something, but it's not gonna give you an extra thing, or it's gonna give you an error, I forget. But if you want to do a specific number, let's say you want to do a 4, that's where you use an index. You use the square brackets, and then you type a number. So I'm gonna use the top ones because it mostly looks like a Lua, so I'm gonna use the top numbers. The index of this is 3. If you do this, it's gonna print you 4, because the third number in the A, or the third index in the A, is 4. Okay. So funny thing is, you can actually in Lua, I'm not sure about all the programming languages, but you can actually also store different types, which means you can put strings, integers, like everything into there. Then you can also have keys. Then you can make it even more confusing. You can make such a confusing array. Oh my god, I'm gonna try to show you. I'm gonna call it B. It's gonna look really confusing, and I'm sorry if it will. You already know it's cooked whenever I have to put one all the way over here. Let's see, we're gonna call this, let's call it corrupted, okay? I think it goes equals, bam, I think it goes something like this, whatever, and then we can have, I think that's how it goes. Let's see, what should we talk about? Like I don't know, like gender or something. Like equals to it's a string, male. Then I have, I don't know, what else can we have? Height. It's gonna be like 5, as in 5 feet. I don't think you can put inches as well, but whatever. We're just trying to get to you. And I think you said you do B corrupted. I think you put another one, and then you put like gender, and then it's gonna give you this. So you can like have this called a key. The index gets changed to this, and yeah. So I go to this one, I find corrupted, and I find my gender. That's all. Really simple. It gets confusing, but it gets also easy. Some people may already find it easy, depends. But that's alright, in a nutshell, really. I have one thing called files, which is a memory thing, and the thing about it is, whenever you're coding, whenever you're making things, I don't know, like Roblox, stupid, like a game or something, remember, as like the game is playing, imagine you have like, tycoon game. Remember this, like, yeah, they still exist. Remember your tycoon, and like you're building stuff. You build, like you're. What am I drawing? This is the tycoon, right? You like build it. You have like all these droppers. That's not a dropper, but close enough. Looks like sinks. The moment like the game, like, yeah, the moment you leave, all of this is gone. The memory is literally temporary. Temp. Everything that's going on is only here for a temporary time. It's not gonna go away. Storage is permanent, okay? Which in Roblox is something called data store. I'm not gonna write the whole thing, but it pretty much stores your data. Even if you're making just a game, not in Roblox, if you're making any other game, just make sure you have a place where you can store all the data, like players' location, health, like every single thing. Location, health, inventory, hunger, thirst. What else is there? Yeah, disposition, day, night, everything in the world, like if you're big like Minecraft, you know, all the blocks, all the buildings, like all the data, you know, all the data gotta be there, all the animals, all the stuff. Make sure you have your storage, otherwise everything's gonna be erased. Some mobs don't require it, but some mobs, like there's some stuff that will despawn whenever you leave, but I don't think in Minecraft it is like that. I'm not sure. Remember, whenever program ends, no, I'm gonna write it in red. You guys gotta remember this, okay? If program ends, memory. Okay, memory. That can't. Why does my mouse keep doing that? It like stops doing the thing for a second. Memory erased. Okay, everything is gonna be gone unless you store it. Okay, what files do they save data? Okay, you save data into a file. That's all you do, and then you can load the data, and then you can put stuff more into it. Remember, always keep data. Okay, that's as simple as it gets. Next thing is, whoa, I went too far. It's something called object oriented programming, and one of the biggest ones that ever did iOS is Java. Program object oriented. Pretty much. Object oriented programming. Let me. This is such a weird. So in Java, there's something called a class. It's like really weird, and the reason is large programs become unmanageable. If you don't get too much into it, it only really goes if you use a Java or like any other object-oriented programming, which is mostly Java. Or Java is like the most known one for being object-oriented. There's two things. There's an object, and then there is a class. Class is a blueprint. I think it's self-explanatory what a blueprint is, but if you don't know, it's pretty much how your object is built in a way. Like in the you have, you know, your, for example, if you have like a rectangle, the class would be like the height and the width. The width. Okay, so the height and the width. Okay, that's a blueprint. Okay, object is the data plus behavior. Pretty much what you do is you create an object using the class. So whatever you do, but it acts like a function. So you type it the same as a function. You write like rectangle, but you put like a variable here. So I'm gonna call like a rectangle. Let's see, 3, 2. So it's gonna be a rectangle with the height of 3, width of 2. It's not gonna make it. It's not gonna be a rectangle. Like you won't be able to see it or anything. It just exists. It just exists in the data, in the system. It just exists. And remember how I said it. The moment program ends, it's erased. Okay. But it creates this object. Okay. Now what can you do with this object? You can do anything with this object. You can like go A, because it's now called A. And like if you have a function about like making it like let's just say you're making like a game and then you actually have a system where it can explode, you can just do explode. It's just if you have that, it's gonna go into the thing. It's gonna like find it's gonna find the aid, which is a rectangle, and then the class is gonna like make it explode. Like it pretty much is. So it gives the data to become this, and then it has a behavior. Okay, that's as simple as I can explain this. This is as simple as I can explain all of this. And then we have final one. My really favorite. I love this. Threads. Okay, what is a thread? So, remember how I told you that the program runs the code from top to bottom, all step by step, and everything step by step. If you like have a while loop, by the way, and like it is never ending, and like I think it has an end here. It's just gonna keep doing it. Like if it's while true, which means it will always run. It's just gonna keep running forever. If you have any code here, it won't run. If you have another while loop here, it will not run. Like these will never run because the while true loop always runs, which means it can never go down. But what if you wanted two loops? Or what if you want something to run while there is a loop? Threads come into the place, okay? So imagine we have a code, okay? I'm gonna use boxes for this. We have a code, then we have a while. Actually no, let's just actually no, we have a code. We have a thread. Then we have a while loop here, okay? And let's just say you want to add like another while loop. Does something else, okay? So the code it goes, right? What thread does is it creates a new thread. Well, and the code still goes, but what thread does is creates another little thread, which means you have two while loops running in one script. You can have two things running at the same time. You have two while true loops running at the same time. Problem is the synchronization and the timing will be really hard to keep track to. Like they can run at the same time. They can run like millisecond late different, and like if you have different weights, it's gonna be like all different, and like keep it the same timing is hard unless you actually make it the same timing. Which you can easily do by like making like one be done and then once the other done they reset, or like it's possible. Don't get me wrong, it's possible, but it's hard. But that's what a thread is. It's pretty much adds more threads to the code. So like you have a code, and like does its own thing. Normal code just does blocks. Goes normally, like from the top to bottom. What threads do? They add more. Like they just add more extra threads, which you can have one code have more what's the word, bro? I'm cooked. More tasks, and in fact, in Lua, the thread is literally called task dot new. Wait, is it new? That's the new task. Oh, got task. I forgot, but you can pretty much create a task and then you can make it a while loop or task that function. I forgot. It just creates a new thread, and you can just put anything into it, or like code, loop, anything, literally anything. And yeah, that's low-key. That's really it. That's all the basics. That's as basic as, like, I told you everything. Now you might be wondering, like, okay, so you told me the basic of programming. You told me like all the like ifs. That's not an F. Ifs, types, or variables. That's a very weird handwriting. I'm sorry for that. I know I can just use text and like types. This and that. Hi, hi, hi. I don't know. I didn't. I just didn't want to. But you might be wondering. Okay, but what do I do with this? How do I actually make something? And sadly, it is impossible to tell you that in this one video because everything is different in every single place. Different programming languages, different sources, as in like Roblox, some is C++, nope, Unity, Unreal Engine, there's another one, I forgot what it's called, Go something, I forgot, it starts with a G. It's all works different. Everything has its own function, own special function. Like I can tell you like the basic stuff, like all of what I just said is like the basic of every programming language, and every programming language pretty much has it, except object-oriented programming. Some programs are object-oriented more than the others, but other than that, everything is pretty much in every single one of them, and like also have like the basic stuff. I guess the object-oriented goes into the basic stuff that you gotta know. Not gotta, but you should, probably, maybe. But really, I can't really tell you much in here about creating something or actually writing. I told you the basic stuff, which if you were to go and hopefully you will try to look at some tutorials, you should be able to know plus or minus understand some basic stuff, like if you see something about if, you'll understand, oh okay, so if it can have it has to have like a variable, like some value, the operator and something, and depending on which again, depending on which programming language, it will have some type of start and an end, or I don't know, depends on, yeah. Then you can have else, you can have else if, then function stuff, and whiles, and for loops, switches, threads, variables, types, operators, all of that stuff. You will see all of these stuff, and hopefully you'll understand at least some of it. And if you'll go to like actual tutorials where people actually like teach you the code itself, because here's the thing, okay, there's some people who don't do that, but some people, they teach you coding stuff expecting for you to understand like how these things work. For example, if I'm gonna make videos on specific languages, specific programs. So I think after this, the first one I'm gonna do is probably the Lua. It is the Roblox one. And when I'm gonna be making this, I'm gonna be expecting some of you guys to know. Like I will still be telling you, oh, this is this, like remember this, remember that. But I will still be explaining, or not explaining, I will still be hoping that you'll understand these things. And hopefully I don't need to explain like what is a variable. There's still some things that I'm gonna explain, like what even is local, because you guys saw me use local a lot. You guys saw me using print. These are like the most basic things. I will tell you, local, print. Don't worry. That's just when I'm gonna be doing Lua, because if you go to Java, it's not print, it's system that out that print. You can put line, put your string here, boom. My handwriting is getting worse. I'm so sorry. What's that? Just to make it better for y'all, system that out. Yeah, no, I'm doing it right. Yeah, so this one is gonna be this little thing right here is uh, the Java's print. So I have the system, and the output print line, this pretty much line, and then string, and then the syntax to end. That's really it. But other than that, if you have any questions, you can ask. I might check. I will check for a couple of times until I'll get tired. So if you got a question and you're not too early, not too early, if you're not too late, you should ask, or somebody else will tell you. Um, I hopefully I gave you enough explanation. Hopefully you guys now know most of this, but if not, apologies. I tried in a way. I'm not sure if that helped this. I hope this helped. I can draw stuff. So again, the first one I'm gonna probably do is the Lua U. If you're up for that, you can just chill. Give that subscribe button. Give that bell. Unless the first 4 videos is gonna be just some games, because I just do whatever I do. But then I'll just do some basic stuff. Probably move to advanced, and then we'll see how that will go. Just looking through my thing right now, just in case I missed something I shouldn't have. And no, I didn't. So, but if you guys can't wait, then yeah, just go look for another language. But that should be all. Circle. Bye bye. Wait, how much did I do it? 2 hours and 22 minutes. Okay, bye bye.